This is a continuation of section 6.3. In this section, we're going to determine the equation of a quadratic function from a graph and then from a verbal description. Well, what we'll do is look at a story problem. So, first set of questions here. Identify the characteristics of the graph and determine the equation of a quadratic function. So the example, we have to find the function that defines the parabola shown here and express it in standard form. Now, we're going to pick out some information before we begin so far. Remember what the vertex is and the x-intercepts. So our vertex, we are at a height of 19 and we are over, looks like 1.5. So you can't have decimal answers, 1.5 and up 19. One x-intercept is at 4, 0. The other x-intercept is at -1 and 0. So use the x-intercepts and express the function in factored form. So y equals a x minus r, where r stands for one of the roots or intercept points, and x minus s, where that stands for the other. Now we don't have a value of a yet. Now what we've learned so far is that if the x-intercept is -1, then we put in the opposite value. And here the x-intercept is 4, so we put in the opposite value, -4. And that's as far as we can take it right now. In step 2, we use the coordinates of another point to solve for the value of a. So we have this much right now. So we could replace x and y with numbers that we knew that were on the graph. We would only be left with a that we could find. And the choice is up to you which points you use. They just have to be points on the graph. It wouldn't be a good idea to use, well, these are all points here on the graph. Anywhere you look down through, you get the x, y value. Okay, I wouldn't look for a point like that because I'd have to guess on what the values were. So look for an intersection. And if I look here, what I mean by an intersection, if I look here, I can see where the graph hits two grid lines. So I'm going to use this point right here. So that would be 3 and 12. So I'm going to sub in this point, 3, 12. So my y value is 12. Don't know the a value, we're going to find it. 3 plus 1 and 3 minus 4. 3 minus 4. So 12. 3 plus 1 is 4 times 3 minus 4, -1. That's going to be -4 when you multiply. Whoops. So over here, now we're going to solve for a, so that means we divide both sides by -4. So it cancels here, so a would equal 12 divided by -4, or a would equal -3. And last step, expand the factor form to produce the standard form. So our final form now, our a value is -3, we have x plus 1, and x minus 4. So this is in factored form. And we want it in standard form. So we have carried all of our multiplications now. So I'll multiply the -3 to everything here. It does not multiply over here. We'll only multiply -3 once. So it'll be -3x minus 3. So we multiplied it here. Now we multiply it to this answer to x minus 4. So -3x times x. It's going to be -3x squared. -3 times -4 is positive 12x. -3 times x. And -3 times -4, positive 12. So -3x squared minus, plus 9x plus 12. If you look back up, just a quick check, our y-intercept here from the equation should be 12, and it is 12.